Hi, this is Leanna. This week we are working with a random number generator. So this program that I'm going to review, it randomly generates two numbers from the range of 1 to 10 inclusive, and then it displays the sum, difference, product, and quotient of those two numbers. So the preprocessing directives that we're using, we have 4 of them now. So the basic input-output directive IOStream, and then we also have something new, cstd lib. This is for the random generator functions, which we'll learn is pseudo-random, not actually random. And then ctime, which gives us one of the time functions, which uses the elapsed seconds since some date in 1970. And then io_manip, which is used for basic formatting, and we can set the number of decimal places for floats and that kind of thing. And here we create our namespace, std, and then here's our startware function. So first, because we want to generate random numbers from 1 to 10 inclusive, let's create some constants and make sure that they are unsigned, which means they're going to be positive, greater than 0, and they are integers. And then using the ctime preprocessing directive, we're getting the time at 0, which is 0 seconds, or this is just, time 0 is just the general way to get the number of elapsed seconds since some faraway date in 1970. And then we're setting seed equal to that number of elapsed seconds. So then we're using the srand function to pretty much grab that huge number and then use that huge number to pick one of the many, many, many sequences that the algorithm generates. So every time you run this program, you'll be using a different seed number, which means you'll be getting different sequences of random numbers. So next, let's initialize some variables. Let's do 2 integers for each of the random numbers that we're going to generate. And then this over here is just getting the, just making sure that we're doing 1 to 10 inclusive. So we're getting our random number and then getting the remainder. And so 10 minus 1 is 9, plus 1 is 10, and adding 1. I'm actually not sure what this does, but it was in our textbook and I'm using it because it works. I should probably read a little bit more about that. Anyway, next we have our sum variable, or difference variable, or product and quotient variable, and I'm assigning those to the data type double because eventually we want to have 2 decimal places per our program requirements. And here are the calculations based on the random numbers that we generated. Next, we are using the io_manip file to set the precision for decimal places and make sure that applies to the double variables. So now we're going to display the calculations. Here's a string literal and our random number that we generated, and that's basically it. We just print these statements one after the other, and then we use sin.get to pause the program, say press enter to continue, and then we signal the end of the program with the return 0 statement. And that's it. So let's see how this actually looks in the compiler. All right, so we have the sum. The two random generated numbers we have are 2 and 5, and then we have 2 decimal places for the actual calculated field. And press enter, continue. We're done. Thank you so much for watching. I did forget, wait. One of the challenges of doing this was initially I was having trouble just getting the random, all of these solution variables to have floats as opposed to like all of the variables, including the randomly generated numbers, to have decimal places. So like I was, instead of printing 2 plus 5, it was 2.0 plus 5.0, and that was annoying me because I only wanted 2 plus 5 without the extra decimal places. So what I ended up having to do was assign the random number variables as an integer. And that way the set precision statement didn't affect the random number variables at all. And that's it. Thanks for watching.